Welcome to Jacked Engineering. Today we'll be going over LeetCode problem number 26, remove duplicates from a sorted array. So let's go ahead and read the problem. The problem says, given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same, then return the number of unique elements in nums. So let's go ahead and draw out what that would look like. So if we have the example highlighted here with an array containing numbers 1, 1, and 2, that is going to return, let's say this is equal to array A, right? Well, that means that A is going to be modified so that A is equal to 1, 2, okay? So we're not going to be returning a new array, right? So we're not returning a new array. We're actually returning the amount of numbers that are in this updated original array. So what is the actual algorithm for this problem? Well, it's going to work like this. We're going to take 2 pointers, okay? We're going to have numbers 1, 2, 2, and 3. This is a pretty simple problem. So we'll have 2 pointers. We will call them I for insertion, and we'll have J because I is, J is the other convention, right? So what are we going to do? Well, if the previous number from the insertion point, or from J, if the previous number from J is not the same as the number at J, then we are going to insert a number at the insertion point. So we are at 0, we're at index 0, so that means that we can go ahead and fill in our first number because there is no previous number. Then we can increment both I and J, right? So then we have I is here and J is here. Now, what do? We go, the number at index J is not equal to the number at index J minus 1. So that means that we can go ahead and say that the number at the insertion point is going to be equal to the number at J, right? And in this next step, we will see how the duplicates are filtered out. So now we have our array, which is going to be 1, 2, this is going to still be 2, and this is a 3. We have our I, and we have our J. So now you can see that J, right, the number at index position J is equal to the number at index position J minus 1. So we're not going to increment I, okay, so we're going to leave I where it is, and we are going to increment J. So we have 1, 2, 2, 3. So finally, we have I in a different position than J. We can now see that J, the number at index position J does not equal the number at index position J minus 1. And therefore, we can go ahead and insert at the insertion index the value of J. Okay, and what is that going to do? That's going to leave us with an array that looks like this, which is going to be 1, 2, 3, 3, right? And I is still going to be right here. Okay? Well, because I is at this last position, right, and we're no longer looping through, well, coincidentally enough, the value of I is actually how many unique elements that we have in our remove duplicate array. So let's go ahead and code this. We're going to say for int we said j. So for int j is equal to 0 while j is less than, let's make this bigger and easier to read. There we go. Well, j is less than nums.size. We'll go ahead and increment j, right? We'll also have our insertion index that will start at 0, I is equal to 0, and we will say if j is equal to 0, well then we know that we can just say that nums at I is equal to nums at j, and we can increment our pointer. Now, the other condition, right, which is where we can use the j minus 1, else if j, nums at j is not equal to nums at j minus 1, well then we can go ahead and do our logic where we say that nums at I is equal to nums at j. Okay, we just have to increment I again. One other condition, well, we also need to check that. We don't need to check that because we're in an else if statement. I was going to say that we need to put something here that says if j is greater than 0, but because if j is equal to 0, then only this statement can be triggered because we're in an else if. Okay, zoom out just a little bit so you can get a bigger picture of the full thing. And what are we going to do at the very end? Well, we're going to return I, right? Because we figured out that the amount of elements is actually going to be equal to the index that I is at by the time that j is done looping. So we'll go ahead and run. We'll get an error because of that semicolon. We'll run again, and we will get test cases 1 and 2 passed. Let's go ahead and submit and see if we pass all the test cases. So there we go. We are in the fastest of the bunch. So this is, to my knowledge, the fastest of the solutions. So that'll be all.